Greetings, everyone. My name is Ahmed Ibrahim. I am a researcher and doctoral candidate working in artificial intelligence, cybersecurity, data science, and digital transformation. Today, I will introduce AquaAccess, a research initiative that supports United Nations Sustainable Development Goal 6, which focuses on clean water and sanitation. AquaAccess targets a persistent challenge in rural communities: the lack of reliable systems for reporting water quality issues and for accessing trustworthy water data. The project focuses on regions with limited or absent broadband connectivity. It examines how AI-driven tools can support water monitoring in these underserved environments.
Hello, this is Amina from Al Khalifa Street. The pump is dry again. Please, we need a tanker here. People are waiting.
Amina's situation reflects this reality. She reaches the village well, finds the pump out of service, and cannot report the issue because she only has a basic mobile phone. Her entire town eventually waits for someone to discover the problem. These delays stem from inefficient communication channels, outdated reporting systems, and limited broadband access, which prevent communities from using conventional mobile applications. Rural communities, especially in the upper and delta areas, continue to experience repeated failures in water service delivery. People walk long distances to wells or pumping stations and often find contamination or broken infrastructure. The core issue is the lack of a fast, reliable way to notify authorities, which leaves problems unreported for days and exposes families to avoidable health risks. AquaAccess addresses this gap by enabling residents to submit water quality concerns via SMS or USD. These alerts flow into dashboards used by local authorities and NGOs, enabling faster dispatch of technicians and quicker on-site assessments. This streamlined reporting process creates the foundation for more accurate, actionable water quality intelligence. AquaAccess uses a polyglot data integration model that combines several independent sources to create a complete picture of water conditions. Sensor arrays provide real-time measurements of pH and turbidity. Community members add crowdsourced reports through SMS when they notice contamination or service interruption. Government data from the Ministry of Water Resources provides infrastructure maps, testing records, and maintenance information. NGOs and research partners contribute field observations, while offline SMS inputs ensure participation from communities with limited connectivity. Historical archives help identify trends over time. By merging these diverse streams, AquaAccess avoids dependence on any single data set and builds stronger situational awareness for residents, technicians, and decision makers. With this data foundation in place, the next step is understanding how the system delivers this information to its user interface. The user interface follows a design philosophy that reflects the realities of rural communities. When the application starts, it identifies the user's approximate location. It links them to the nearest water source, such as a tank or extraction well. The system avoids household-level precision and instead shows the regional source serving the area. A resident might see data from Nile Riverbed, South Section, or Il Minya West Tank, which provides clear transparency about what the platform monitors. The water quality screen presents the latest measurements, including overall status, pH levels, and bacterial counts. Residents can also request expedited testing. When someone notices a problem, they submit a structured report describing the issue, and the system sends it directly to local water authorities and partner organizations. Technicians receive dispatch notifications, visit the site within 1 or 2 days, and collect samples for laboratory analysis. Results return within 5 to 7 days, and the interface shows this timeline, so residents know what to expect. Community updates, service advisories, and historical trends are also available in the app, helping households understand changes over time and plan for seasonal risks. These features form the visible layer of AquaAccess, supported by a larger system that integrates data, analysis, and coordination among multiple stakeholders. This diagram shows the full system architecture. AquaAccess accepts multiple input streams, including offline SMS reports, IoT sensor data, government datasets, NGO field observations, and USZD submissions from basic devices. All of these inputs flow into a central intake and validation layer, where the system checks data quality, detects anomalies, and ensures each record is usable. The analytical layer merges these sources and applies domain-specific logic. It identifies water quality anomalies, detects service outages, assesses contamination risk, and generates predictive alerts when conditions indicate rising problems. After analysis, the system distributes outputs through several channels. Residents receive alerts through SMS, USD, or the mobile app. Technicians receive site-specific task assignments, and water authorities access dashboards that summarize regional conditions and operational trends. The timeline follows a realistic operational pace. Communities submit reports on day 1, technicians investigate within 1 to 2 days, and laboratory analysis finishes within 5 to 7 days. This transparency sets accurate expectations for residents. The architecture also functions without consistent broadband connectivity by relying on SMS, USD, and sensor inputs. This approach ensures accessibility in rural and underserved regions. With the problem, data model, interface, and infrastructure defined, the next question becomes how to scale this system sustainably. AquaAccess operates as more than a reporting tool. It acts as a bridge between residents and the institutions responsible for water management. Each SMS report, sensor reading, and field observation becomes actionable intelligence that protects vulnerable communities and strengthens water system resilience. The next stage of this work depends on collaboration. We are seeking partnerships with government ministries, local organizations, NGOs, academic institutions, and philanthropic supporters who share the goal of expanding equitable access to water. Our current focus is scaling pilot programs to additional governorates across Upper and the Delta. To support this expansion, we are pursuing $3 million in seed funding to cover sensor deployment, field staff training, laboratory integration, and system infrastructure. With the right partners, AquaAccess can scale across multiple regions and offer a replicable model for other water-stressed areas. Reliable water information should not depend on internet access or digital literacy. Every household deserves clear, timely insight into the water they rely on. Thank you.